So this says fill in the table below with exact, not decimal, values. And what that really means is don't use your calculator for this problem, but you're certainly welcome to use your calculator to sanity check the problem, but I want to see the actual fractions. And also, because you're supposed to be showing all work, it's not enough to do them on the calculator and then kind of reverse engineer what, that's what it means. That's exactly what it means. But it reads, fill in the table below with exact values. Okay, so the easiest part is this part first. So let's convert radians to degrees. Very easy. 180 degrees is equal to pi radians. Or you could do 360 equals 2 pi, whatever. So wherever you see a pi, you just put in 180. Okay, 180 over 4 is 45. You don't even have to write the degrees because, well, it's there. It says degrees and radians, so you don't have to write that. Okay, how do you turn degrees into radians then? Well, let's see. So you would just multiply by pi over 180. Okay, this is what you're doing. If pi equals 180, you multiply by pi and divide by 180, that's 1, but what you're doing is changing the units. So it's 60 divided by 180. Well, that's 1/3. Okay, so that's pi over 3. So you technically weren't supposed to be using your calculator for that, right? But that's what that is. Same process for 90. 90, to get from 90 to 180, you just multiply by 2. So this must be the pi over 2, right? Is this correct? So think about it. If you put the pi here for 180, 180 over 2 is 90. Yep. All right, let's see. 2 times 180 over 3. 2 times 180 over 3. 120. 9 times 180 over 4 is 405. Why does that look obnoxious? Because really this is pi over 4, because we've wrapped around the circle. Okay, and what's 360? Again, you can multiply by pi over 360. Let's not use the calculator. You get rid of sets of 3, then that would be 10 over 12. You can get rid of another 2 as well. That's 5 over 6. It's 5 pi over 6. I'm sorry, my 5s sometimes look like S's, so try to fix that. Okay. Now, we have a couple easy ones. The first 3 are easy, and the other 3, well, I mean, this one's easy because you're just going to copy that. But if you didn't notice that, it would be hard. Okay, so 4 of them are easy. And show all work. So these ones, well, you wouldn't technically have to show this, but it would be nice to. Okay, so 45 degrees is over here. And so your triangle is going to look like this. And so this is y, this is x, and this is r. And we should remember sine, cosine, tangent, cotangent, secant, cosecant. And if you do SOHCAHTOA, that's, you know, that's what you do. Same thing. Put little notes on the side, remind yourself. Sine is y over r, cosine is x over r, and tangent is y over x, cotangent is x over y, secant is the reciprocal of cosine, so you just flip it, r over x, and cosecant is the reciprocal of sine. So there's our little cheat sheet. One last thing we have to remember. Sine is y over r. There we go. Cosine is x over r. Yep. Tangent. All right. Now we do the reciprocal thing. Tan and cotan are reciprocals. Secant and cosine are reciprocals. Sine and cosecant are reciprocals. Yay. 60 degrees. Okay. So this is half of an equilateral triangle. So we're going to ignore this half, but I'm drawing the picture so you can see it. This is 60 over here, so 30 is the other one. And so what does this look like? Alright, so I'm going to have to use a different color. Actually, it's going to be hard to see if I don't change the color of this guy. Okay, so I'm going to write on top of him. This is 2 to 1 ratio, because if it's half of an equilateral triangle, it has to have a 2 to 1 ratio. And so this side here, I'm going to have to do some erasing, sorry about that. Okay, so this side over here is square root of 3. And this one is x, r, y. So we go back to our sine is y over r, cosine x over r. Now we can just forget about the triangle. Sine over cosine is root 3. Reciprocal of that is 1 over root 3. Reciprocal of a half is 2. Reciprocal of sine is 2 over root 3. Okay, this one you can do a number of ways. You can just, if you remember what the curves look like, that's sine, that's cosine, and you remember 90 degrees is a quarter of the way around, then you can remember that sine is 1 and cosine is 0. Let's say you don't remember that. You can pretend to draw yourself a triangle that's, you know, the 90 degrees would be here. You'd be making this go up and up and up. And you'd be, so for example, you can't do 90 degrees, but let's do like really steep. A really steep triangle would look like that. So maybe that's 80 degrees. What would a 90 degree triangle look like? Well, that would be 0, that would be 1, and that would be 1. So as you go to 90 degrees, r goes to 1, y is like 1, x is like 0. Alright, so if that helps you, you can draw that crazy triangle. That's the alternate way to do that. Sine over cosine is, whoops, 1 over 0 is infinity. However, 0 over 1 is 0. And reciprocal of 1 is 1. Reciprocal of 0 is infinity. So there you go for that one. Alright, we already know that this is the same as 45. So since we figured that out, we can just go ahead and copy these in. There we go. So that one's easy. And then we have 2 that require a little more thought. So that 2 pi over 3, what's happening here is you've got, it's 2/3 of a pi. So if you cut the pi into 6 pieces, then it would be like that. Okay, roughly. And then you'd have 60 degrees over here, a 30-degree wedge, a 90-degree wedge. And so the question is, the reference angle. Yep. There we go. The reference angle would be 60 degrees. And then we have a very similar situation to what we had over here. We have 2, 1, square root of 3. But it's actually -1 for x. Y is still positive, and r is always positive. Now we can go ahead and do our sine and cosine and all that stuff. Sine is y over r, so it's the same as 60. Cosine is x over r. And then you have to figure out which of these get changed, because tangent comes from sine over cosine, so it's going to just get a negative sign. And cotangent is reciprocal of tangent, so it's going to get a negative sign. And let's see, secant is the reciprocal of cosine, so it's going to get a negative sign. Cosecant is not going to get a negative sign. There's all sorts of memory devices to help you remember the sequence of sign flips, where sine is S-I-G-N, sign flips. But I don't really like using them. I'd rather just have you draw the triangle and figure them out. At this stage, that's the better way to do it. Later, you can do whatever you want. Okay, now we got another one of these. Okay, 300. What is 300? Well, it's easier to think of 300 as not quite 60, right? So there's got to be 60 degrees missing right here. And of course you're going to end up with all the same pictures again. You're going to get a 2 here, a 1 here, and a square root of 3 here. So 1 is equal to x, but this is going to be a minus square root of 3. Alright, so go back to the drawing board. Sine is y over r. Cosine is x over r. Tangent combines both of them, so it's going to get the negative sign. So is cotangent. Secant is the reciprocal of cosine, so it does not have a negative sign. Cosecant is the reciprocal of sine, so in this case it does have a negative sign. Okay, I think that's all I wanted to cover in this particular question. There's lots more to say about trig, but I'll just leave it to another time.